Hi everybody, my name is Aníbal Azevedo and now this is the third class of the track 2 about how we can apply artificial intelligence technique in a supply chain operation. More specifically, we are dealing with a container ship port problem. So now we're gonna continue the last development of the last class. If you didn't see the last class, a card will appear somewhere. Okay, so what's important now, we're gonna use some code from previous class, but more important than this, we're gonna use the code that we made, but with some difference, okay? So let's start to code again, and we're gonna produce a new unloading rule for to unload container ship. Okay, this is the code of the last class. This is the description of this class. So why I'm looking for this? Um, it's important because we're gonna use some of them. So here I have the code from track one. Let's go copy here. This is the Google Colab environment. Okay, so we're gonna copy some code here. Okay, so I also should start this code, should execute this code because this code is gonna uh, have some variables. More specifically, we have this CS1, which is a container ship object, and we can have some values to test or unloading rule. Okay, so now, okay, we already defined an unloading loading rules section. We're gonna create a new text here. It's important to make the code organized and documentation with documentation. And now we're gonna create a new unloading rule. Okay, so this is the first unloading rule. I will not apply this because I already tested this code, but I will remain this code because we're gonna use for some to accelerate our work. Okay, so now we're gonna produce the unloading rule 2, and this unloading rule 2 will unload all containers with destination port v and the ones which are out of order, out of up out of sort sorting order. So these containers, what are the examples of these containers? For example, this stack here, this column, we have container 4, and clearly when we arrive at port 4, we should remove this and also the containers which destination are port 5. So this stack is not correctly is not in the correct order, also this stack and this stack. So using this second unloading rule, I should remove all containers from this stack, from this stack, from this stack, and also this, because container 1 is not in the sequence, the right sequence, because we should remove them when we arrive in port 1, and before we should remove them, and also port 2 and port 4. So I should rearrange this stack, okay? So now what I should do, I should code. Okay, let's code. So just before this, I add a cell, which are where I can insert my code, and I start to define def unload R02 CSP. Okay, now we have we're gonna use some things that we already defined on previously function. Here, this is very important. This first part, because this part we can just copy because this is a short name for CS cargo map and bay and dimensions of the ship, and finally the parameters that should be returned. Also, we can copy the return and the test that we should perform for this function. Okay, so here are the things that we should copy from the previous function, the unloading rule 2, 1, and now we should create this new function. As you can see, we also take some time to define some important names here. So what I should do, I can copy all things here. It's very, we can also see that many things here we can use, okay? But what's important now? We have this command here to find the container in a stack, in a specific stack, and this command to find a specific container in a stack or in a row. It's not the only one command that we can find some index container, the starting index container. So there is another manner that another operation that we should do. What is this another thing? We should verify if there is some in this stack, if there is some kind of this inversion. For example, the container 4 is under a container 5, and this situation is the situation that produces that the thing that we should remove all containers starting from container 4. So how I can verify this situation? I start a loop here, and this loop gonna be something like that. So imagine index out order or order. Okay, so these indexes start with any link. This is the uh, number of rows minus 1. Why minus 1? Because the index starts from 0 to n number of rows minus 1. Okay, this is how the Python create indexes for lists or list of lists or arrays. This is the way that create these things. Okay, so using this, I can create now row in range, or I can create line blind in any line. And why I should not compare this loop will be a comparison. I should compare, for example, 4 with 5. I should compare 5 with another 5. But I should not compare 5 with another what? There is nothing on the top of 5. So I should make comparisons not until I find the last component, because the last component I will not compare with anything. So this is minus 1 also. Okay, so finally the index out order will be len. Okay, we are not sure if this is true or not, if it is appropriate or not, but we put this value. And finally, if ship, we should use ship here, ship, and we use bay, use len and column. And this is the kind of situation that we are trying to identify, that this value 4, for example, is lower than another container that occupies a higher row position. So this is the situation that we are trying to identify, and when we find this, we should break, apply a break. Okay. break because we're gonna carry this lean index, and this is what we are wanting. So else we continue to find, we continue your search in finding the element that's not in the correct order. So I should update this in index out of order. I should update this to lean plus 1. Okay, I should update this value until I find the last element here. Okay, and finally, what we can do here, it's important to say that this will continue until I find the last element. And it's important to see that if I find the last element, I don't need to remove all containers from this stack. Okay, so suppose that we are in this last element, maybe we don't need to remove any component or to rearrange any component here. So this is will be the last element, and maybe this is not necessary any kind of rearrangement in this stack, right? So what we can do here, just to finish this, if index out of order is equal to any link minus 1, so I'm in the case where I don't have any kind of problems. I don't need to change anything in this stack or in this column. So I should clearly say that, okay, this is not the case that we should rearrange or put something out of this stack. So I should use this. Okay. Okay. So after this is important part of the code because we're gonna use index of containers that should be removed and index of out of order, and we should combine then in one index that we should apply um, before this if. I should use if uh, I should verify this condition. It's important. And what I should do, why I should do this, because I'm gonna produce another index which is minimum index of containers to be removed, array containers. So this index is the minimum of this value and index out order. And this is the thing that we're gonna use on this if, but in a different form. Okay. Else, what can happen? We can return nothing if we search it about P. So in this situation, we don't have containers to be removed or to be unloaded on this port, but on future ports, we have this kind of stacks that's not right, it's not correct. Now, should we rearrange this? Okay. So for this situation, let's see again. Okay, it's here. So I produced a minimum here, okay? Else minimum index array containers will be. Now we should remember that this is the index out of order. Okay. Now, what is important to verify? The first thing that we should verify if we need to change something in a stack is to verify if this minimum index array containers verify is lower than any lim. And if it's lower than, we should start to modify all things starting from these minimum index array containers. Okay, so instead of applying this start index container, we're gonna use this minimum index array containers. Let's change this to this. And since we are everything here is related with elements, it's now okay. It's in principle. And also this, we should change it here also. Okay. So now we have all things correctly posed, and we have this ship in this manner. Let's check out if this uh, function is correct and it's working properly. Let's see. Okay. So now, as you can see, we removed all containers from the container ship, which is not correct because here we should remove this, okay? We should remove this and this and this and this. Yeah, it's okay. So remove everything because everything is out of order. As you can see here, it's out of order. Here it's out of order. And here, everything it's not okay. Or and it how much effort we're gonna spend by doing this. This is an important thing. Here are the containers that we should reload again. So we have free number 3, 2 number 4, 3 number 5, and or 4 number 5, 2 number 6, and 2 number 7. Let's check out here. Okay, okay, 4 number 5. Okay, 2 number 4, and we have some containers which destination is port 1. So we just don't check out because they are not higher than p. Okay. Okay. So how many movements we made by doing this? uh we posted this 19. Let's check out and have. Okay, why I'm get this number 19? Because we are not counting the containers which destinations port 1. I know that is not quite correct because we are counting containers which destinations port 1. We should count them. Um, One manner to avoid this kind of error is just to pose something like that. And we can see all containers, and let's check out if it's work. Oh. Okay, let's reload again this container ship because we don't have more containers there. Okay, now we have already have containers in the container ship, and now we are counting all containers, including the ones that okay, not zero. Zero is not correct. Let's check again. So we are counting also containers which destination is port 1 or port, no matter if I'm in the container port 2 or 3. If you have some containers that should be unloaded, you should count them. And if you want also to include the containers which destination port 1, you should include this, okay? You should modify this because this is the way that we can count in containers which destinations port 1. Generally, we are gonna apply these rules considering a certain port, and we're gonna use simulation to start from port 1, 2, 3, 4, 5. Okay, so here we have containers which destinations port 1. So I don't think this is the right idea, because in the right case, when we are in port 2, we already passed on port 1. And that's why I will keep this implementation by doing the following thing. This is the reloaded containers. So I will see the future ports. And here we're gonna count all containers that should be unloaded starting from port P, because we already passed from port P minus 1, minus 2, and this is the right way to count. So, okay, I made something not right here. Okay, let's do it again. Let's reload this variable. So I will not count containers which destination is port 1, because in the correct case, since we are in port 2, we already unloaded containers on port 1. There is no sense on doing this since we don't count containers on port 1, okay? So this is the right implementation. I will keep this implementation, and I hope you understand this. If you have some difficulties to understand this code, please leave some comments, or also remember that in the comment description of this video, you have all codes you can modify for your situation. If you find this is not okay for you, okay, you can change for your situation, okay? That's it. Thank you for your attention, and I hope you find this useful. In the next class, I will start to create the loading rules, the functions related with the loading rules. Thank you, and see you on the next video. Bye!